In this video, we'll be looking at using direct and inverse proportion and how to calculate what's known as the constant, which is symbolised by the letter K, that's used to express a proportion as an equation. We'll also be looking to solve proportion questions with the equations used to represent proportionality and also recognise the shape of the graphs created from the different proportional formulas. Before watching this video, can I recommend that you watch the linear equations and the solvent equations lessons, as they're heavily referred to in this video. Here we have a simple proportion of y is proportional to x. This symbol is referred to as the proportionality symbol. Simply put, this means that as x gets bigger, so does y, by a proportional amount, which is referred to as a direct proportion. The slope of this line is referred to in the linear equations lesson as the gradient, but when we're talking about in terms of proportionality, it's referred to as the constant, and we use the letter k to represent it. Therefore, if the value of k is 2, the line would increase by 2 on the y-axis for every increase of 1 on the x-axis. This is symbolised here in this equation. Let's look at an example. Here we have a proportion where b is directly proportional to a. When b equals 24, a equals 8. Firstly, we need to write an equation for b in terms of a, for which we'll need to find the value of k. And then, using that equation, we're going to find the value of b when a equals 12. We can write the proportionality of b to a as this, and then change it to an equation with the knowledge that a direct proportion will involve multiplying a by the constant of k. We can then substitute in the known values of b and a to solve for k. b equals 24, which equals k times a, which equals 8, or 8k. We can then divide both sides by 8 to calculate k to equal 3. If we now rewrite the formula as b equals 3a, we have answered the first part of this problem. Now we can substitute in our value for a, which is 12, to solve the equation for b. 3 times 12 equals 36. Remember that we calculated our constant by using the known values of a and b. Let's have a look at direct proportion when there's a power involved. Here we are told that y is directly proportional to the square of x, or x squared. We're also given that y equals 30 when x equals 4. The question asks us to write an equation for y in terms of x and then calculate the value of y when x equals 6. The proportionality will be written as y is proportional to x squared, which we can then convert into an equation by including the constant of k, and writing it as y equals k times x squared. If we then substitute the known values for x and y, we'll get 30 equals k times x squared, which we can then write as 30 equals 16k, as 4 squared is 16. If we then divide both sides by 16, we find that the value of k is 1.875, and we can now write our equation for y in terms of x. Y equals 1.875 x squared, which answers the first part of our problem. In order to find the value of y when x equals 6, we'll substitute 6 in for x to get y equals 1.875 times 6 squared, which equals 1.875 times 36 and gives us 67.5. So we can state that y equals 67.5. In both of these problems, there was a direct proportionality, meaning as one variable increases, so does the other. In an inverse proportionality, the opposite happens. As one variable gets larger, the other gets smaller. Let's have a look at what happens when it's an inverse proportion. In this instance, we're going to say that y is proportional to 1 over x. Now, if you remember about what happens with fractions, the larger the denominator, the smaller the value of the overall fraction, if the numerator stays the same. In this case, as x gets larger, the value of y will go down. For example, a half is larger than a third, and so on. So as x goes up, y reduces, forming this curve that we have here. You'll notice it never touches the x or y axis because you can never divide by 0, and the numerator is always 1. In order to find the constant, we need to write the equation with the k, or the constant variable. And we write it like this. Y equals k over x. This is our equation for an inverse proportionality. Let's have a look at how that's going to work in a question. Here we've got c and d, which are positive numbers. We'll come back to that in a moment. And c is inversely proportional to d, so that when c equals 7, d equals 28. We need to write an equation for c in terms of d, and then we need to find the value of c when c equals d. I'll show you how we do that in just a moment. First off, let's write it as a proportionality, which is c is proportional to 1 over d. From this, we can write our equations by substituting the constant k for 1 and changing the proportional symbol to an equal sign. In order to calculate the value of k, we can substitute the value of 7 for c and 28 for d. We can then multiply both sides by 28 and get 196 equals k. This can then be substituted in for k in our equations to get c equals 196 over d. We're then looking to find the value of c when it equals d. So let's multiply both sides by d to get c times d equals 196. As we're looking for c to equal d, we could say it's c squared equals 196. If we square root both sides, we get c equals the square root of 196, which is 14. So we've solved for c when it equals d. Remember at the start of the question it says c and d are positive numbers. Otherwise, you'd have another answer of negative 14 at this point, as the square root of 196 is either 14 or negative 14. Both of those numbers square to make 196. But as we're told that they're positive, we know that we can only have the one answer. Now let's look at a problem with an inverse proportionality that includes the use of a power, or a root. Here, y is inversely proportional to the cube root of x, when x is positive. We're told that when y equals 2,500, x equals 64. We're asked to write an equation for y in terms of x, and then asked to find the value of y when x equals 8, and to find the value of x when y equals 2,000. Let's start off by creating our equation from the proportionality, which is y is proportional to 1 over the cube root of x. We can substitute our values for y and x to get 2,500 equals k over the cube root of 64. If we calculate the cube root of 64, we're going to get 4, which means that we can write it as 2,500 equals k over 4. Now, if we multiply both sides by 4, we get 10,000 equals k. We have our constant, and we can write our equation y equals 10,000 over the cube root of x. Now we want to solve for y when x equals 8. Let's substitute 8 in for our variable of x. We get y equals 10,000 divided by the cube root of 8. The cube root of 8 is 2, so y is going to equal 10,000 divided by 2, which equals 5,000. So y equals 5,000 when x equals 8. Now, to find the value of x when y equals 2,000. First, let's substitute that in for y in our equation to get 2,000 equals 10,000 divided by the cube root of x. We can swap the 2,000 and the cube root of x by multiplying both sides by the cube root of x and dividing both sides by 2,000. This gives us the cube root of x equals 10,000 divided by 2,000, which equals 5. If we cube both sides, we get x equals 5 cubed, which equals 125. So when y equals 2,000, x is going to equal 125. Now, let's look at some of the graphs that are created by these proportionalities. Here, we have 4 graphs and 4 types of proportionality. We'll probably find the easiest one for us to pick out is the first one, of a direct proportion of y is proportional to x. There's no powers greater or less than 1, so it's going to be a straight line, which leads us to think it's going to be graph 3. We've got a constant gradient, so it must be this one. Next, we have y is proportional to the square root of x. Let's complete an xy grid using some of the squared numbers for the values of x, 1, 4 and 9. As these numbers get bigger by a larger amount with each increase, the value of y will increase by only 1 each time. 1, 2, and 3. So we're looking for a curve that is not increasing as much on the y as it is on the x-axis. And it looks like graph 2. We can see this if we roughly plot the values in. This seems to work. Now we're looking for the graph for y is proportionate to x squared. Again, let's create an x and y grid to plot some of these values. This time I'll use consecutive numbers for x, which will create the squared numbers for y. So when x equals 1, 2, and 3, y will equal 1, 4, and 9. So this graph will slope sharply up, and we can see that in graph 1. So is graph 4 the one that shows y is proportional to 1 over x? Again, if we use an x and y grid and use the first 3 values of x, we get x equals 1, y equals 1. When x equals 2, y equals a half, and when x equals 3, y will equal a third. So the value of y is getting smaller with each increase in x, but to a smaller degree each time. It will never reach 0, as you will always be creating a smaller and smaller fraction. Now, we've got all the proportionalities labelled with a graph. Let's review what we've done. We've calculated the constant variable k that's used in a direct and inverse proportions. We looked at using those equations to solve proportional questions using direct and inverse proportion. And then we've also looked at the shape of the graphs created from the different proportional formulas, and how it's a good idea to actually map those out using an x and y grid to ascertain which one it is if you can't spot them straight away. In the next video, we'll look at compound interest and depreciation, which looks at how growth and decay can be calculated mathematically. I'll see you then.